Good afternoon, good morning, good evening, regardless where you are. How you doing? My name is Pierre Roman. I'm a cloud advocate with Microsoft, and today I am joined by Vinicius Apolinario.
There
I
you
get that
go.
right?
Well, not entirely, but like I said before, I do appreciate the gesture.
So what are we going to talk about today?
Well, talk about designing a container build strategy.
Okay.
And you guys can follow along in the link or the QR code that you see there.
Yes, aka.ms/learn live 2022 1031A. It's almost like we should come up with something that's rolls off the tongue a little easier, but that's basically the date. And I want to make sure that everybody knows that this particular module is part of a learning path, which means a whole bunch of different modules that is specifically designed for anybody who is studying or looking at potentially taking the AZ400 exam. So implementing continuous integration with Azure pipelines and GitHub Actions. So that's part of that learning path. So after you have done this one with us, go back and check out the entire learning path. It's really, really cool.
Yep. If you haven't already, go there and check. And what the thing is, we'll be making a few assumptions that you know some of the stuff about Azure DevOps that we're going to cover in the session today. So if you have questions, please post those questions. We can answer throughout the session, but we will cover mostly the container design and how to design a build process for Windows. Not just Windows containers, Linux containers as well. It happens that I'm focused on Windows containers for our team.
And I am a complete noob where containers are concerned. So I went through it, and I'm going to tell you what I got from it. And I'm going to be asking some questions, Vinicius, that hopefully you can set me into the right path.
Yeah, absolutely. That's the goal.
Okay, so today the learning objectives are as follows. First, we're going to figure out how to design a container strategy. We're going to work with Docker containers. We're going to create an Azure Container Registry, so a registry that is outside of Docker Hub. So if you've got deploying on Azure, this is your go-to place. And then explain what microservices and Docker, how this all fits together. Cool?
Yep.
All right.
Let's do it.
Let's go. So if we're looking at introduction, this is a learning path. So if you are very, very familiar and you're working with containers every day, it's great that you're around and ask some questions. But this is really as the introduction for people like me who are kind of new to containers. So a container is the third model of virtual computing, if you will. So, and they are here to stay. Like I've been around for a long time, and I remember like the days when when virtualization still happened, and everybody was saying, "Oh, that's just a fad; it'll go away." And now virtualization is everywhere. It's actually rare to see an actual physical server running. Container is the third model of that, and it's here to stay. We're going to go towards that. It is really just a way for us to not to obfuscate, but separate the physical to the virtual. So we're looking at benefits that are open, so it's portable because of the way the container is made. So you can take it from one virtual environment and deploy it in multiple virtual environments very, very easily. Number two, it provides a consistent environment. So if there are any devs out there or IT pros, the excuse that it works on my machine no longer an acceptable excuse. So go if it works in the container environment, it will work in every container environment that is set up the same. Correct?
Yep.
Okay, perfect. Are lightweight, and we'll talk about that a bit more when we get towards the virtual machine comparison. So they're very lightweight. So you only put into a container what's absolutely necessary for your application, for your workload, for whatever you're going to be doing with that container for it to run. So if you only need like a very light OS and some libraries and a little bit of code, that's all you put in it. So the very, very lightweight, which in turn makes them even more portable because it's really easy for you to move them around, because it's not like moving a Windows machine like 4 terabytes of of code from one machine to another. And the next one is, because they're so small and because they're so lightweight, they're also very efficient in terms of they start, they run, they do what they need to do, and then they disappear. Which is why they're very, very useful in a microservice environment, and Vinicius will go through that later in this session.
Yep. And I mean, just to point out of one thing that is, for me, is very important. These are all related to each other. The fact that it's lightweight doesn't change the fact that the container is efficient, and that also you can package all of the necessary components for your application to be there, so it is consistent as well. We're going to explore how a Dockerfile is built, and there are a bunch of best practices about how to build a Dockerfile. We're going to go through a few of them. And then you can make a container image smaller and smaller by optimizing your Dockerfile. And then you can have the lightweight of a container, you can have the consistency of a container, and then you can have the efficiency of the container compared to a virtual machine. The other thing that I want to point out is, while a container is very good at some operations, there will be others that VMs are still more important than containers, or better suited than containers. If you need an Active Directory domain controller, for example, there's no point in running that in a container. So that's why we don't even have Active Directory as a domain controller in a container, because you don't spin up a domain controller and then bring it down later. You keep it running. So why do that in a container? You can keep it in a virtual machine. You have more flexibility to do that in a virtual machine. So one of the things you should be thinking about that we're not going to discuss in the session today is, what are the scenarios that using a container makes more sense? And what are the scenarios that using a VM makes more sense as well?
So if I understand correctly, Vinicius, we also have to think about the type of application, the type of workload. So in terms of like stateful versus stateless, does that come into play?
That's correct, yes. Now, it's not that containers can't run stateful applications. They can, but you have to check if the environment, if the scenario makes sense to run a container. Now, there will be a bunch of advantages of running a container, but in some cases, you might still want to keep your application in a VM if it's infrastructure related, or because the application is not supported in a container in some way, or just because you get better IT practice or efficiency in a VM for operational reasons or others that might grant the application to stay on a VM. So with all that said, we'll talk about containers. Just keep in mind that you should be evaluating the scenarios where you put stuff on containers or not.
Yeah, and now that I understand like the relationship after I've gone through the Learn module, I can now look at if you have a workload that's running on a VM, because it's stateful and it runs 24 hours a day and it's in a highly available kind of configuration, but it can very easily leverage APIs that are supported by a whole bunch of different containers that are doing their light work, very specialized kind of operation that start, process the information, sends it back to the VM, and then turn themselves off. Therefore, being also very efficient in terms of cost, because you don't have to run those on VMs that are on 24 hours a day. They're just on when they need to.
Absolutely, yeah.
Perfect. All right, cool. So if we go to the next slide, where is my mouse? There it is. the structure of containers, and we've kind of alluded to that also a little bit, is the container basically contains the entire runtime environment of your application and all of its dependencies. So if we look at that little graphics that we have here, we have the server in the OS. So when we talk about serverless, there's still a server. It's somewhere. It's just not your server, and you don't have to worry about it. So we have a host, we have an army of servers that are there that are running in host OS, whether it's Linux or Windows, works on both. And then over top of that, we have our container engine. So in this case, in this lab, we're using Docker, but there are other container engines that are running, and that container engine basically allows you to isolate the container or the application, which is all your code and all of its dependencies into that container. But they do share the server OS and the server kernel and all of the hardware that's underneath. So theoretically, one can affect the other because they are sharing a common structure. Of course, there are guardrails to basically avoid that, and there are ways of isolating those containers. However, this is not something we're going to go through in detail in this particular session. All right, and the next one is the VM. The difference, we talked about the VM. The VM is essentially the same thing, but the whole OS is virtualized and isolated. So you have your application, your libraries, and all its dependencies, and the guest OS that is isolated from the hardware. So you still have a hypervisor and a host OS, but your VM, your virtual machine, is basically talking directly to the server or to the hardware through the hypervisor. So then if you have a machine that, as I mentioned, that needs to be completely isolated and has this big workload that runs 24 hours a day, all the time, that is stateful and so on, as Vinicius explained a few minutes ago, then maybe the VM is something that you want to go through. Plus the VM, if something happens to that VM, it's completely isolated and it's not going to affect the other VMs that are running on that shared host. Okay, I think I had the same slide twice. So am I in the right ballpark there, Vinicius?
Yeah.
Did I miss anything?
No, I think we're fine. I think the main point for the audience in this session is going to start now, which is, okay, so they are different. I understand the concept of containers. I understand that they are smaller. It's a different type of virtualization. One is the hardware, the other is the OS. But how do I do this? How do I make it work? And that's exactly what we're going to start now.
Yes. So how do we work specifically with containers? So I also found out that through this, that there's a life cycle to those containers. You work with them, you build them. Once you have them, the actual learn modules talks about pulling them, but before you can pull them, you actually have to push them. So you build a local container, and then you push it to your repository, whether it's Docker Hub or Azure Container Registry. And then from any other environment, you can pull that image down and run it. So you build it, you push it to a registry, you pull it down to the physical instance where you want it to run, and then you run it to execute it. And when that's done and it's no longer needed, then it can be flushed from the system. So that's the life cycle: build, push, pull, and then run. But when we understand the image, when we talk about building the image, we also have to understand how the image is built. So if we're looking at the Dockerfile core concept, I've been in IT for a very long time, as you can tell by the color of my beard. And we used to have these build documents where if you were building a physical server, you had to go and install the OS and then install this patch and then install this driver and then install all those requirements. And This is still the case. It's just automated now.
Yep.
In a container, you have to basically build that script. What I used to have in a binder now is the Dockerfile.
I love the analogy.
Pardon me?
I love the analogy.
Well, it's I was going through that, and I built my own little demo Dockerfile, and it's exactly the same. You've got the OS, so but in this case you don't have. Let me actually, can I switch to a quick demo and then show it to you?
Yeah, absolutely. I think folks are actually looking forward to some demos.
All right, so if I'm in my environment, and let's look at my Dockerfile. And of course, it's opened on another monitor. So let me bring it into place. Okay, that's not working. All right, so let's look at it here, where when I type, our Docker file. Well, so we've got the first one is the OS. So if I was on-prem or in a virtual machine, I'd like basically have to pick my operating system. So in this case, I go from Ubuntu. So instead of installing a full OS to start with, I'm just going to refer to one or a container or an image of an OS that's already built.
Yep.
So I'm going to go here with Ubuntu. There are some other ones that are like very, very lightweight, like some that are like so small that they fit on like the Raspberry Pi that has like a limited amount of storage and memory. But in this one, we start with from Ubuntu. So then our binder, it would be install Ubuntu from CD, and then you'd have to put in the media and install it. Then we give it a label in terms of who maintained this. This particular label I found through researching is actually being deprecated right now. So there are, it still works. But if you are starting to look at building your own Docker file, there are some documentation, and it's at the bottom of the documentation in the Learn module, where you have the Docker file documentation. You can find what the new labels are going to be. Now, once my OS is set and I've put all the labels on it, what I'm going to run on that machine to prepare it. So in this case, because it's a very kind of quick thing, I'm just going to run in a bash the source like home, and so I'm just going to change my directory, and then I'm going to echo to that one, and then I'm going to just say hello world from within the container, and that's it. There's no persistent service that is running. It's just a matter of running that echo line, print that onto the screen. It's kind of like the hello world of containers, and then it disappears.
Yep.
So that is our Docker file. And in this case, if I had application, I could in here put an add statement that you have in the Learn module, where I would add a directory or a bunch of files or specific files to my image that could then be referred to with the next command, which is basically run a script that we've just copied onto that image, and copy your code for running on a virtual machine, not a virtual machine, but a web server or any kind of, or FTP server, or whatever it might be that the workload that you're running for.
Yeah. Just so people know, we're starting with a very simple demo.
Oh, yeah.
We're going to go way more advanced than that inside of Azure DevOps. And the other thing is, more important than understanding each of the steps that Pierre just showed you, is understanding the concept of what you're doing with your Docker file. The most important concept to understand about Docker files is that it's going to take step by step the instructions that you pass on to build a container image. that then can create a container instance, right? So a lot of times I get questions from people saying, but I don't know exactly what to put in my container image or my Docker file, because whenever I install something in a VM, I go next, next, finish, and there you have. That's how I do it. Well, how did you install that next, next, finish? Is it a MSI file? Yeah. Well, an MSI file can be called from PowerShell, and then you pass on the instructions inside of the PowerShell command. All you have to do is figure out what are the commands and what are the instructions that you have to pass on each of the commands to do exactly what you do in a GUI inside now a Docker file. And then you have a documented way, and you have a structured way to repeat that process as many times as you need with an automated in an automated fashion.
Yeah. Yeah, and that's why it's part of the continuous integration learning path. And
Yep.
Steve Metro, I hope I'm pronouncing this right on LinkedIn, is asking what OS can we install for Docker on the Raspberry Pi. Depending on what you're running it onto, there's a number of Linux distribution that will work on Linux, on Windows, but also on Raspberry Pis. You basically have to do a little bit of research. But if it's a container, if it's a standard Docker container, pretty much all of those will work. It's just a matter of which one you can fit in there. So there's some very small ones, like Alpine is a very small one. Then you get the Ubuntu, which is like the full server, and there's a number of them that are in between and of every flavor. So I don't think there's a list anywhere, probably on a Docker website, where it lists all of the supported OS. But it's very easy for you to find it if you're running it, especially for Raspberry OS or Raspberry Pi, to say container Raspberry Pi. There's a number of them that are available to you.
Yep.
Okay. All right. Let's go back to our deck. So we've built our custom image. We've built it using my virtual binder, has-built binder. And I've listed all the steps that are needed. So now that I've got that, so we have to look at, but before I go to the next step, we've built it. So right now I've got my Docker file, but we actually have not actually built the image.
Correct. Yeah, you have a Docker file, which are the instructions, and now you need the command to actually go and build the container image.
That's right. And normally you would just go like Docker build, and if you're doing it on Linux, there's the command might be a little different. Right now I'm in PowerShell, so I'm using the get content of Dockerfile, because Dockerfile is just a text file. So I'm getting the content of Dockerfile and I'm piping that into the Docker build command, and the -t or -- tag is basically to give it a name that is easier to reference than the very long GUID that it's going to come up with. So if I go hit the enter on that, it goes out, gets the information from the Docker file, downloads the Ubuntu section, gets the information from my run commands, runs through all of that, and now it tells me that I have, as you can see, I've written an image, and the color is a little off, but written an image that with that long GUID and named it Pierre Roma /learn live at the latest version. So if I make modification to that image, now can have a V2 or V3, and you can actually keep track of your changes and track of your versioning through this process. Now, I have it. So and see that in my image, I've got one that I downloaded that I pulled from my repo earlier, and I've got the one that I just created. Well, I created it a while ago. I'm just did it again. And then I can actually run it. I'm running for my run command, which is Docker container run, and I give it the name that I want to run. It tells me it ran it very, very quickly. Hello world from within the container, and then it's gone. But if I go to Docker PS or for Docker process, the container is no longer running. It ran, it did what it needed to do, what it did in the Dockerfile, which was just to prompt hello world from within the container. And then once it was done, it closed, and now it's done.
And you can even run there, Pierre, docker ps -a, and it's going to show that the containers ran what it did and it stopped. You can see that the command that you ran and then the exit status, because there was nothing else to do in the container, so it exited 37 seconds ago.
Okay, perfect. So that was it. So a very small Dockerfile created an image. When that image is now living on my machine, and I can either push it to a registry or pull one from a registry. And I think Vinicius is going to talk about ACRs, so Azure Container Registry, in a bit, and how you can upload those images. But for now, let's move on to the next section, because that was really simple. Like, that Dockerfile was like, even I understood this. So the next step is, how do we work with multi-stage Dockerfile? So a bit more involved. So Vinicius, can you take us through that?
Yeah, absolutely. So while simple, again, it's a strong concept of you can take whatever process you have to build your application, put it in a Dockerfile, and then get an image that is reproducible, is going to execute consistently between environments. So development, testing, production environment, on-premises, cloud. It's going to run exactly the same way. I want to take a question first from Kevin. He asked about the option to get a MSI file and put it in a Docker file through a PowerShell command. And yes, Kevin, that's the silent installation option. There's no next finish on PowerShell. You can call the MSI file if you have a GUI, but specifically Windows containers don't have a GUI. So GUI-dependent apps don't work on Windows containers. But then if you need to install an MSI file and you would need the GUI just to install the application, then what you can do is you can use a solid install with the parameters properly configured to go and install your application without the need of opening the GUI to do that. So with that said, let's take a look at some more advanced examples of using a Docker file. There's a bunch of concepts here. Please send us your question, but ultimately we recommend that you keep exploring how containers work, including the concepts that Pierre just went through. So let me move on to the next slide. Oops, I think I'm on the wrong place. That's where I should start my section. I apologize about that. So let's take a look at multi-stage Docker files, because what Pierre showed you is a simple Docker file, but also all the instructions were configured in one image, right? And at the end of the day, there's a bunch of commands that you might need to run in order to run your image. So I'm going to use an example of a more complex one. And this comes from the module. So you've seen this if you are following along. And basically, you can see that we have additional from statements. So one of the things that Pierre mentioned was you can use the from statement to say, this is where I'm going to start. I'm going to start from Ubuntu, for example. And then on top of an Ubuntu image, I'm going to deploy my application. Well, in theory, you can only have one from statement, which is where you want to add your image to be used. But with multi-stage Docker files, what you can do is you can bring up multiple images that are built that are used to build your container image. Let me explain that. When you run the Docker build command, what happens is in the background, Docker engine is basically using a image in a container instance to go execute something and then close the instance to then go and create your container image. So each step that it runs, it brings a container, runs something, close the instance, and save it to your container image, right? So if you take just the top there, what we're doing is we're starting from the ASP.NET core image from the .NET theme to run .NET applications. And we are establishing what is our working directory, which is where you want to start inside of the context inside of that image. So we're going to create a folder called app. We are going to expose the port 80 and 443 for HTTP and HTTP requests. And that's it pretty much for that image. But then what we're doing is we're starting from another image, and notice that the from statement not only says what image to use, but also as build. And the first stage was actually as base. So the base stage is our final image. In that case, is the base image that we're going to use. And then the next stage is going to be used as a build, because as part of building my application, I have to compile the .NET application that was written by my developers into a binary that can be used to deploy the application, right? So what I could do is I could write a Dockerfile that has everything in it, but I don't need the source code of my application inside of my final image.
Well,
I
you
only
may
need
not
the
want. You
binaries.
also, Vinicius, you may also may not want to have your source code in the container that is accessed. Because this is proprietary information.
Absolutely. And not only that, it's additional storage that you need, right?
Okay. Yep.
So your image is larger now because you are storing files that are not going to be used when the application is running. Your source code is one thing. Your binaries that are compiled already are a different thing, and only the binary files are needed for your application to work, right? There's a bunch of stuff you can do here because of that. In fact, if you examine the Docker file that the .NET team uses to create their own images, few things that they do, they use multi-stage builds, and as part of using multi-stage builds, you could potentially even use images that don't necessarily interact with each other. So to better explain that, in Windows containers, for example, we have the concept of having either a nano server or a server core image. So nano server is like 300 megs in size. It means that you have a full Windows OS in 300 megs. It's ridiculously small. The server core one is for existing applications that you are containerizing, so it's larger. It's like 3.4 or 4 gigs in size, but that's understandable because you're taking applications that work today into a container. What they do is the .NET team builds part of their process with a server core image, and then they copy the content from that image that was used only as temporary thing for as part of the Docker file, and copy to the nano server image. You can mix and match container images that are different in this process. So continuing on this case here, I'm going to move to the next slide, which is explaining each of the steps here. So the first one is the base image. So we're saying we're going to use this as base image, and this is what the configuration of the image itself needs to be. It needs to have a directory called app, where I'm going to host the binaries of my application, and I need those ports open. That's it. The next one is I'm going to use this part of the Docker file to build my binaries from the source code. And so you can see that we run .NET restore that basically looks for packages that are missing, NuGet packages and those kind of things. And then you have the .NET build command. The next one is the publish, which usually is along with the same process of the MS build. But here we are putting in a different stage, and I'm going to explain later why I'm doing that. And then the final one is, well, I'm going to take everything that was created before, and now I'm going to copy only the things I need to this one. So what happens here in the fourth stage is that we go back to that working directory and we copy the content from, as you can see, the publish stage into the final one, which is the fourth stage. So that's the only components that are being brought into that image. So the image is smaller in this case because we used multi-stage build. Everything else is not necessary, so it's going to be thrown away in this process. And then the end result is a smaller container image that you can use. Now I mentioned, sorry, go ahead, Pierre.
I was just going to say, so it's if we were doing it the old-fashioned way, we'd do everything, and then we'd have to go back and then basically clean out all of the stuff that we don't need, that we don't want to expose. In this case, we avoid the cleaning out, because we only take what we need at each stage in order to build to the final stage.
That's correct.
Perfect.
Yep. One of the things that we did here was, why didn't we use the publish stage along with the build stage? And one of the things we talk about is all the steps that you see in a multi-stage Dockerfile, they should follow your process. So what is your process to build your application? This is the default one to build any .NET application. You do the build, then you do the publish, and you might have an additional step for testing, right? So what happens here is that when you run a test, it will use only the components from the build, so you don't need to wait for the publish process to run for running a test. The advantage here is, if the test fails, I don't need to go to the next stage for publishing, because I just wanted to check if the app, if the test passes or no. So if it passes, great, I can continue later with the publishing process. If it doesn't, then I didn't have to wait for the publishing process before running the test. The other thing is, why are we using the base image as a first stage? And you can argue that this is just workflow, but in reality, one of the things that you have in Visual Studio is, when you run inside of Visual Studio, you are basically calling Docker, and then what Visual Studio is doing is it's targeting one of the stages that you see here. If we had the base one at the end before the final, or along with the final, I could put in, what happened was, the Visual Studio on your machine, when you run locally and you try to test your application inside Visual Studio, it's going to compile the application, and then it's going to use a target for which stage to use. If it was last, it will have to run all the others first to then get to the target one, and then run the application for you from inside Visual Studio. Because we put it first, Visual Studio compiles everything, bring the very first image, stage, which is, because it's the first one, it's faster to create. And then you can start testing and validating and seeing your container in action from inside Visual Studio, without waiting for the other stages to finish to get you to the stage where you need the application up and running. There's a bunch more. There's so much more to do with Docker files. In fact, we have documentation on how to optimize Docker files. Docker has a bunch of good documentations on how to optimize Docker files. I'm just going to mention one here that comes from top of mind that you can use, and it's a simple one. You can see that we have some run commands in here from the Docker file. Now, the run inside of a Docker file, it's either calling bash on Linux or some other, I can't think about anything else other than bash right now, but on Windows, it could call either command prompt or PowerShell, right? You can imagine some applications that will need more than one run for more than one command each time you deploy the application, right? So what you could do is you put run step number 1, run step number 2, run step number 3, and there you go. You have it done. But remember that every time that you run a Docker build, Docker is going to run each of the lines, building a new container based on that step, and then closes the instance and save that layer, that layer that was used in that process, as an additional layer on top of your container image. So at the end of the day, your Docker image is a bunch of layers, one on top of the other.
But each layer kind of represents that command or that item that was in that Docker file.
That's correct. Yes. Now, one thing you can do is you can run one command, multiple commands in one run. You can, there's a way to do that. You can use escape, which is either backslash or I forgot what the name that we use when backstroke, I guess.
The little tilde kind of like symbol there.
Yeah. So depending on how you build a Docker file, you can use escape to go to the next line. So basically what you do is you have a run, and then either bash or command prompt or PowerShell, and then you bring up the command, and then you put the next commands with escape. So each line will represent a different command, but they are all packaged inside of one run. What that's going to do is it's going to create one single layer. So you have a smaller image because you ran multiple commands in one run. So again, there's a bunch of stuff. There are multiple ways to make your image smaller, and making your image smaller is a good thing with containers, because you make the process of pulling your image to your hosts that are going to run your application faster, and you also spin up your container image faster as well.
Yeah, that's all about making containers as efficient as possible, as we mentioned in the very beginning of this session.
That's correct. Now, a few other things that we can do for container images. Modularity. So what that means is you might have an application that has multiple tiers of the application to run. Some people might think, well, can I put all tiers in one container? You can. Should I? No. Ideally, what you want to do is you want to segregate the instances that can run individually. The other thing is I might be containerizing an existing web server. Well, your web server might have like 100 different websites. Should I put them all in one container image, or should I put them in separate container images? Well, it's going to be a lot of work to put in container images for each of the websites, but when they run, they're going to run better, and it's better management for you when they run in separate container images.
Not only that, is if you have an update to do on like one site or one of those layers, you don't have to redeploy this container on all the instances that are running that. You just basically update the instance that's running that tier of the application.
Yep, absolutely. Speaking about size of container images, avoid adding unnecessary packages. It's common between development environments to have things that you think you need, but when you build your container image, make sure that you really need those packages. Again, this is just to avoid a larger container image. You don't want to put anything inside of the container image that you don't necessarily need in the production environment.
It's also a security topic, because the more dependencies and the more packages you put in there, the more you've got an exposure to if one of those packages gets compromised somehow. If you don't need it, don't put it in there, and basically shrink your attack vectors.
Yes. Yep. The next one is to choose an appropriate base. Now, there are two angles, at least in my perspective, about choosing an appropriate base. The first one is you want to make sure that your container instance is going to run properly in the production environment, right? Especially on Windows. This is true for Linux as well, but especially on Windows. If your host, for example, runs Windows Server 2019 and you build a container image running 2022, it's not going to work. There needs to be a match between the version of the container image and the host in order to run Windows containers. This is less true for Linux, but you might run into some issues if you are not making a good compatibility between host and container. The other side of that is, in my opinion, make sure you're choosing a container image that you trust, right? Now, there's a lot of debate about secure supply chain on containers, because on Docker Hub, anyone can go and publish an image. And you're looking for a specific framework. Make sure the framework you're using is provided by a asserted vendor, certified vendor, or it's the vendor that you're looking for that actually built that image. There's a bunch of toolboxes on Docker Hub. You never know what the people put inside of that container image, and you're going to put that in your production environment to run. So make sure you trust whoever published the image that you're using as a base.
So if you're using a Windows Core or a Windows Nano server, make sure it's the image that's provided by the Microsoft publisher. Or if it's Ubuntu, make sure it's canonical, and so on. So if you've got Bob's Web Services that's publishing a Ubuntu base, Maybe I would think twice about
Yeah.
putting that, because you have no idea what Bob put into that layer.
That's exactly it. By the way, the Microsoft ones are always hosted on what's called MCR, or the Microsoft Container Registry. So whatever image you're using from Microsoft, could be a Linux or could be a Windows image, should have the mcr.microsoft.com address as part of the image name. Avoid including application data. And this is not source or binaries. This is what is your application writing into the OS. Uh, Containers should be ephemeral. So what that means is that a container should not have data that is persistent to the container itself. You can present volumes and persistent storage for containers so they can store that data. But if a container goes down and another container instance goes in based on that container image, you should be able to bring up a new container looking at the data that was persisted outside of the container that you used before,
So,
right?
so it's basically a logical link to an external storage array or external storage of some kind, a database, flat file, whatever it may be, where your container itself never has nor never saves any data itself within the
Mhm.
container. So if it crashes, you just flush it and spin a new one. Or if you've got all of a sudden a an increase in demands or more connections coming, you can spin up like a second or a third or a fourth or a 100th or a thousandth instance to support your load, but they're all connecting to that storage link.
Yeah, that's exactly it. And again, it's the concept of microservices. You don't want to have dependencies for specific container instances. It's fine if something is in the container image in terms of how the application is going to work, but not data or nothing that should be persisted should be inside of the container image.
It does remind me of this old saying that you treat your servers as cattle and not
Yeah.
pets.
Yep. All right. So now that we went through what Docker containers and what containers are, how they can help, how you build a container image, um, and some best practices for creating container images, uh, let's explore some of the Azure services that will help you throughout your life cycle for your scenarios around containers. So the first one, oh, actually, they're not listed here. So I'm going to go through them one by one. So the first one that we wanted to talk about is Azure Container Instance, or ACI. And what ACI is a service on Azure where you just give it the container, and basically what happens is the service is going to run the container for you. This is great for applications that you need to scale up or down, or that you don't need access to the orchestrator. Orchestrator being a tool that will help you run multiple container applications, or dealing with scaling for large applications and high volume or high demand applications. Examples of orchestrators: Kubernetes and Docker Swarm. Talking about Kubernetes, Azure Kubernetes Service, or AKS, that's a managed Kubernetes service from Microsoft. And what it is if you deploy Kubernetes yourself, you see that you have to manage a master node or a control plane, and then your worker nodes, which are the nodes that are going to actually run the applications, or with the pods or the containers that are hosting your application. Now, what a managed Kubernetes service is, or AKS, is you don't have to deal with the control plane. Microsoft is going to run that for you. You only take care of the management, the worker node side. And then you deal with the nodes, how many nodes you need, what is the configuration for the node, and everything else. But all about the control plane, you don't have to deal with that. Microsoft is going to run that for you.
So we take care of the boring stuff, is what you're saying.
That's correct. Yes.
Okay,
What this allows you to do is it allows you to focus on the application itself, right?
cool.
Uh, Azure Container Registry, so ACR, and what ACR is basically a registry, much like Docker Hub, that allows you to create private or public registries where you can host your container images. The reason why registries are important is because as you build your application inside your dev machine, you want to have this in a public location, or when I mean public location, I mean it could be a private or public endpoint that either only your company can access or anyone in the world can access to go and publish the container image so hosts that are running in the production environment can go to pull the image or download the image, as we used to call this in the past, download the layers of your image to that host so they can run the container instance for you.
Yep. And one thing we didn't really cover earlier, and as you mentioned that, especially with the registry part, is when you pull the image, if you've already got the base image, if you've already got some of the layers and they haven't changed,
Yeah.
you're not going to download it again. So only the part that's changed gets downloaded if you run it again, which makes it a lot more efficient because you don't have to re-download the whole thing over and over again.
Yep, absolutely. Actually, one case here that is relevant. So Microsoft publishes security updates for Windows every month, right? Every Patch Tuesday. Well, guess what? Windows containers also get Patch Tuesday, but they don't have Windows Update. So the way for you to update your Windows images with the latest security updates is by pulling the new image and then deploying it again in your environment, right? If you are using something like DevOps, this should not be a problem. But then the point to what Pierre just mentioned is you don't have to pull the whole image again. It's only the layers that changed from the latest build to the new one. So it's a smaller pull that you have to do.
Yep.
Finally, the next one is, well, two final ones. Azure Container Apps. So Azure Container Apps is much like ACI, Azure Container Instance, but it is a Kubernetes orchestrator that you don't have to deal with anything about the orchestrator. You just provide the YAML for deploying your application, and it runs the application for you and the other necessary infrastructure components for you. But different from AKS, you don't manage the control plane, but you still have access to the whole orchestrator there. You can add add-ons, you can change the configuration for Kubernetes, you can add a CRD that allows you to run VMs on Kubernetes or other things that Kubernetes was not made to do. You can add those things. You can change the configuration of the orchestrator itself. Azure Container Apps is based on Kubernetes, but you just run the application. It's an additional focus on just running the application, but in the Kubernetes model. And finally, Azure App Service, which is our platform as a service service for web applications. And the reason why Azure App Service is relevant for containers is you can run directly your application and then we deal with the infrastructure, or you can give us a container and run it on Azure App Service, which, by the way, the demo we're going to have right now is based on Azure App Service as well. All right. So with that, I think it's time, and people might be waiting for that, to look at some more demos. And the demo here is actually based on the lab, right? So it's a 60-minute lab. We have 37 minutes to finish the session. So what we did prior to the session was we started the lab already. So let me move into the lab here and bring up the lab page. So this is the module, right? So if you're following along, you are at this point at the deploy Docker containers on Azure App Service web apps. And at the very bottom of this page, you have a link to launch the exercise. And what this does is it brings this page, which is, again, a 60 minutes lab. And it's probably going to take you a good hour to go through all the instructions over here, but we're going to do it less than that because we ran the prerequisites already. So the lab starts, and I'm just going to explain what's happening around here. We did this process already, so we can save time to the demonstration. So basically what this says is, well, the first task you have here is you have to configure the team project. And again, just taking a step back, the goal here is to deploy a Docker container to Azure App Service as a web application. So the first step is to configure the lab requirements or the prerequisites. So we're going to start by creating a team project in Azure DevOps. So if I go to my, where is it? Here. If I go to my Azure DevOps page, you can see that I have my VNAP organization. And inside this organization, I have a project called Deploying Docker Containers to Azure App Service Web Apps. This project was created for me using the Azure DevOps demo generator. And you see here the steps that it does to deploy the whole thing on Azure DevOps. So basically what you do here is you select a template, you choose to click the template, go to Microsoft Learn. I have to refresh this. I'm going to cancel for now. Let me just sign in again so I can finish the.
That is security.
Yes,
that is security at works. So you don't walk away and let a session logged in with your credentials.
Correct. So basically, what I'm showing here is I have the Docker template. I can give it a name, and this is the name that I provided before. This is the organizations that I have access to my account. I selected the VNAP, and I basically create project. Everything on the Azure DevOps side is created for me. So you see that we have a project. If I go to boards and work items, there's a bunch of work items that were created already. If I go to repos, you see that the repo of my application was already uploaded to this project. Everything was pre-configured. Everything up until this point are discussed in the other modules, as Pierre mentioned before, that are part of this learning path. So we are assuming you understand this concept already. And let me go back now to the instructions and just go over what we just talked about. So you use the Azure DevOps demo generator to create a project. And once you create a project, you click Navigate to Project, which then goes to the page that I just showed you. Next, what we need to do is we need to create the Azure resources that are going to be used by the Azure DevOps project in order to run. So what we do here is we open a Azure Cloud Shell from the Azure portal. We select the option for Bash, and then we run the following commands to first set what are the variables that are going to be used for what is the location you want to deploy, what is the name of the resource group, what is the name of the Azure Container Registry, the app service plan and the app service name, the SQL database server and the SQL database name. So these are all variables that then are going to be used in this script over here to create all the resources. Like I said, I ran this already, so I can go back to the Azure portal and show you. Let me close the Azure Cloud Shell for now and show you that I have a resource group. And if I click the resource group, I have all the resources here. I have the app service and the app service plan. I have the container registry. I have my SQL server and my SQL database, and this all was created for me through the Azure DevOps demo generator. I'm sorry,
Okay.
That's the Azure DevOps part. This was the script that I just mentioned.
Yeah, I'd like to mention that once you get a little more advanced into setting up your GitHub action or your CI/CD pipeline within Azure DevOps, all of the creation of those services can be automated.
Yeah.
It's just to keep this lab very specific onto using or deploying a container in a web app on Azure. They kind of separated creating of the resources or the services in Azure that are required to run that web app separately, but it can be automated as part of your CI/CD pipeline.
Yep, absolutely. The final thing that it does here is I ran this command over here that basically sets the connection string for my SQL database into this variable, and then configures Azure App Service web apps with this connection string for the SQL database. So this pretty much allows the Azure App Service to talk to your Azure SQL database.
Yes. And this is a again, as a security person, being an operations person, those secrets, those connection strings, those credentials, anything like that should be kept as secrets in Azure Key Vault, in GitHub Secrets. You don't want to have those in your deployment scripts.
Yep, absolutely. And this is where the fun begins, which is now with all the infrastructure in place, let's go and deploy the Docker container to the Azure App Service web app using Azure DevOps. So the first thing we're going to do here is we're going to configure the CI/CD. And like I said, let me go back real quick to the Azure DevOps page. Because what I wanted to show you here is that because this came pre-configured, it already pre-configured the pipeline, right? What I wanted to show here is that, let's see, where is this one? Edit. No, it's not this one. There's something I wanted to show here. Yep, there you go. So what I wanted to show here is the trigger for this pipeline, which is the enable continuous integration. So what that means is if something is changed on the source code and committed to master, what this is going to do is, because I selected the branch here, what this pipeline is going to do is it's going to start the build from the moment that it was committed to the master branch. Now, as part of the lab, that becomes a problem because we have a few things to change in the lab itself. So it's going to run while not everything is properly configured. So the first runs are going to fail. But the last one, where everything is configured, everything is in place, we're going to make a change to the code that is reflected in the application, and then it's going to run properly. So with that said, let me go back. I'm going to leave and not save anything. I'm going to go to repos, because the first thing that the lab asks me to do is to go change the Docker Compose file. Now, we didn't talk about Docker Compose. Let me just go copy this and change on the file. But Docker Compose is a specification on how do you build a multi-container application. Now, specifically for our case, we're going to use this as part of our CI/CD pipeline, and Azure DevOps is going to use this Docker Compose file to see what does it have to build in order for the pipeline to work properly. So it's not just the application itself. There's an additional container that needs to be built as part of the pipeline just so the application can properly run. We are using Docker Compose for that. So we are bringing an existing container that was created specifically for this application in this environment. And we can see that in this file over here, which is a Docker Compose. And what they are asking us is to change this one to this. I'm going to click Edit. Change this one to this image over here. So I'm going to go commit and update the Docker file to master. And I'm going to say commit. And there you go. Now, the thing is, it started the build process in the background, although we haven't properly finished the configuration for the image. For the application. But since I changed something in the master branch, it's going to start that. Ideally, in a real environment, you will not be doing this. You're not editing anything inside of GitHub or Azure DevOps. You should be doing this in your own dev machine. Use a different branch, and then you merge your branch.
Do a pull request.
That's like what calls the
proper DevOps practices.
Exactly. But because this is a lab, we're doing this directly in the code, in the master branch, committing directly from Azure DevOps, and it's gonna work in the end. So it's fine. Next, what they are asking us to change is change the from statement for the Docker file in my application itself. So I'm gonna do is I'm gonna go to the source, myhealth.web. This happens to be a health system application. So I'm gonna go to source, my health web, And here I have the Docker file along with the other files for my application, of course. And I'm going to change the from statement here. I need to click edit. Don't do this at home. Commit. And I'm going to commit directly to the branch from Azure DevOps. And it's all fine.
This is normally in production when everything goes wrong and you wonder what happened.
That's your good and old test in production. All right, so now in the web browser with the Azure DevOps, I'm showing our project. We're going to go to pipelines. So let's move to the pipelines. And next, what we're going to do here on pipelines, we're going to click the entry for the pipeline for the build. So let's change. We're going to edit a few things for the build pipeline. So let me go back there. You see that it's showing the recent runs, right? So I'm going to click all. I'm going to click this. I could check this one. Let's see. And then we'll click edit. Yeah, it's just the same one. All right. Yeah. So here's part of the process, right? So you have the run services, you have the build services, and you have the push services. And this is all used to run the steps that I need. And each of these steps need to be configured with the Azure resources that we used in the previous step that were built for us. So what I'm going to do here is we're going to, let's see, it's talking about what are the pipeline, what are the tasks that consist our pipeline. Just so you know, I just got an email from Azure DevOps saying that the pipeline failed. I can show the email later, but that was expected because we're not finished. And then we're going to go to agent specifications for that one. Agent specification. So it's asking me to use Ubuntu 18.04. That's already what's in place. Then I'm going to go to the run services and then look at the Docker Compose. And then, here what I have to do is I have to use my Azure subscription from the drop-down list over here. And I have a few, but this is the one I want to use. You see that it's not authorized. So basically what this means is you need to authorize the Azure DevOps service to access this Azure subscription. And you need to be the owner of the subscription in order to do that. Or you need to have contribute rights to that subscription in order to do this, because you are you are creating a service principal that is going to be used to access the Azure environment. So it asks me to authorize. I can click authorize here. I believe I'll have to log in here unless the session is already logged. While it does that, let's look at what's next. I'm going to do the same then for the run service. Then I'm going to select the Azure Container Registry from the drop-down menu. So once this authorized, the list of Azure Container Registries available in my subscription will show up here. I don't know if there's a pop-up or something that came up, but basically, it's just creating the authorization. This might take, there you go.
There we go.
Finished.
It took a little longer.
Yeah. It does create a service principal in the back end, so it does take a few seconds or minute, I should say. Like I said, now that it's authorized, I can select the Azure Container Registry. And remember, this is exactly the registry that was created in the previous step inside my Azure subscription. I think that's it that I have to do here. I also have to change the same thing for build services and push services. So I'm going to go to build service. I'm going to select the same one that I already authorized. This is one per project. You don't have to do this for each one of these. So there you go, push service. I'm going to select the same one. And here's the registry. So basically what I'm doing is whenever this service is run, this is the subscription to use, and this is the container registry that is going to store the image. All right, so now on the same pane, at the top of the pane, save and queue. And I think it's just save, right? Yep, save. Let's go. So we're going to save. I don't have to provide a comment here. It's best practice that you do. So everything you do is actually documented and you explain why you're doing something. But
you
basically,
took the words right out of my mouth on that one. I was going to call you out on that.
Yep. Now we're going to go look at the releases, which is whenever something is built, what does it do with that? Not exactly artifact, with that image.
Mm-hmm.
So we're going to look at the release, and then we're going to edit this release over here. And here what we're going to do is on all pipelines, on the release pipeline pane, on the rectangle for dev, click the 2 jobs and 2 tasks. And then it describes what we have here. And basically this is my web application environment, and this is the database environment. So basically what this does is, if we look at the configuration that we have over here, is to execute the, not execute, so this file over here that you see is basically the configuration for your Azure SQL database configuration. So let's look at this one and then the database deployment. And basically what it's asking me to do here is the Azure subscription. And it's going to list the... Oh, yeah. Oh, sorry. I already have this as part of my web application. It was one of the steps that I did earlier. So now the Azure App Service deploy, because remember, when I ran the thing about the connection string, it was part of the web service inside of Azure App Service. So now all I have to do here is to say on the Azure DevOps side, when you run the web app deployment, this is the subscription to use. And if I remember correctly, I also need to change the agent pool for the database and the web deployment. So
and the app service name, yeah.
And the app service name to be used, yes. So this is the app service that was created previously. The image source is the container registry, and then the ACR is going to be used. This is coming from the pipeline. So now DB deployment, this one over here. So database deployment is a Windows Server 2019, and that's all right. And the web application deployment, this is a Ubuntu 18.04. Great. So basically, this will configure how my environment is going to look like before it takes the image and then deploy to app service. The next thing is we're going to look at the variables. And the variables is interesting because this allows you to use different configurations for each environment that you might have. So let's say you have an A/B test kind of configuration, and you want to have different settings for your A/B testing. So you can have variables for one environment and variables for other environment. The same way as you have your different pipelines for each type of environment of development, testing, and production. You can also have variables that point to different databases and different kind of things. So what we're going to do here is we're going to change the variables for, let's see, pretty much everything. So what I'm going to do is for the ACR, I need the whole identity. So I'm going to go back to the Azure portal. I'm going to go look at the Azure Container Registry, and I'm going to click the access keys. I'm going to copy this logging server. Oops, this one, and I'm going to change this to my logging server. Next, I'm going to change the database name. So then I'm going to go look. Actually, I think that part of the instructions, database name is unique. The password, the username for that's SQLadmin. And then now this is one that we need to get from the SQL database itself, which is a database.windows.net. I have this here that I saved from before.
While you're looking at for the variable, this is why the CI/CD pipelines are so powerful, is because you can have a set of variables for your test environment, for your dev environment, for your pre-prod, for your prod. You can have as many environments as your own processes and guidelines, DevOps guidelines tell you to have. And have a set of variables so that the username and password for the production is not the same as the username and password for your test environment. And by doing that with a variable, then you don't end up having to go and change that username and password or credential, or even if it's an address of a SQL server, because you don't want to like deploy a test and target your production server. You want this to be all
Encapsulated.
included or encapsulated. Sorry, thank you. Into those the environmental variables.
Yeah, absolutely. And the thing is, because we have a Docker file that describes how to deploy something, it's just easy for Azure DevOps to go follow those instructions and just deploy the thing for you. So that's the whole point of having this automated via a Docker file. But let's move on. I'm running out of time, and I do want to see this working. So what I'm going to do now is to trigger a build. Remember, every time we commit something to the master branch, is going to trigger the build and the whole pipeline to all the way to deploying this to Azure App Service. So what we're going to do is we're going to look at our repo. We're going to open a file that has something called contact us. Join us. We're going to change to contact us, which is what the web page says now.
Yeah.
So here, again, don't do this at home, but I'm going to go to source. Where is it? Views, home, and this is the file that is asking me to change. The line is the line number 28, and I'm going to change to contact us. So join us. I'm going to say, of course, I have to edit first.
But that's good. It's good. So you can't accidentally hit and put some typos into your code.
Yep. So again, I'm going to commit directly here. And because I did that, if I look at the pipeline now, I can click runs, and yeah, there you go. Just now I started a new run. If I look at this, let's see, releases. Let me go back to where can I see? So pipelines, this one.
Summary and jobs.
Summary and jobs. I think it's at the, there you go, at the bottom. So yeah, this is the process that is running in the background. So check out Docker at master. Then it's going to run services, then build service, then push services, and then in publish artifact. I don't think there's anything as post job configured here, but that's it. Now, the main difference here, if you decide to use VM, is time. I believe this will be concluded earlier than the next 10 minutes that we have left for the session. You will never do this with a whole VM if you decided to do that. And I see a bunch of questions there.
I think Laurent took care of some of those questions.
Oh, okay, that's great.
But we only have a few minutes left. So while this is running, do you want to jump into the knowledge check?
Yes, that's a good idea. So let me move on to the PowerPoint deck again. We talked about the scenario. So, okay, so knowledge check.
Which of the following commands do you use to retrieve an image from a registry?
Yes.
Oh, we talked about this, so
we're
not running it. So it's a pull or a download, as we said that used to be called.
Yeah, well, we used to call when you retrieve something from the web, we used to call this a download back in the day.
Yep.
Now I think it's called a pull process. So yes, this is pull.
All right, question number 2.
Yes. So sorry, go ahead, Pierre.
No, it's okay. Which of the following choices is not container related to Azure service? So A would be Azure App Service,
Which is exactly the demo that we're running.
which is the demo we're running, and we've already explained that it's kind of like the underpinning of some of the Azure container services. Azure Container Instance, or ACI, names in it, so I assume this would be a container related, or a VM scale set. I think it's pretty obvious here that we've already said that the containers and VMs are completely separate. So I would say C is a virtual machine scale set is not related to containers.
Yep. Now, the thing here is you could actually spin up a VM and run containers on top of it.
That's right.
But it's not a managed service. So app service, ACR, ACI, those are services that were specifically created for the life cycle of containers. Right. Final one. Which of the following choices create an instance of the image? And
yeah, that's a trick question, isn't it?
That's a tricky one.
Because if you just go straight to the word create, you'd say, okay, I want to create my image, but no, it's create the instance of an image.
And here it has to do with the terminology more than anything else. Because I'll give it a second. Let's check how our environment is before we answer this one. I think people might have already. Oh, there you go. It finalized everything, so everything is now completed for the release. Let's go back and answer that one. And here the thing is, the terminology is you build a container image, and then you run a container instance based on the image that you built.
That's right.
Right. So it's Dockerfile.
That's right.
All right, let's go back to the lab, and let's take a look at the next instructions. But I think what it's going to ask me to do now is to check the application running, but it's asking for something else as well.
No, you just have to go into the Azure portal and get the URL to see if our container is actually running.
Yeah, basically it's asking me to look at the releases, and then, so if I go release, if I go to this one, yeah, so it built the everything from the pipeline, is now deploying to app service.
Oh, okay.
Yep.
So it's not completed. It created the build,
yes,
and now deployed the database. Now it's deploying the app service. Okay.
Yep. This again will take a few seconds. If you have any additional questions, we still have a few minutes. We are just pretty much waiting for this to complete.
So while we're waiting for that, let's go back to the summary and figure out or review what we've learned today.
Yep. So let me move on here. Yep.
So we kind of talked about the container strategy at the beginning. So the differences between containers and a VM, and the life cycle of a container. So you create the image, you push the image to a registry, you pull it to the host to where you want to run it, and you run an instance of that image, which kind of worked with Docker. Container registry is one of the registries that you can use to push your image to or pull your image from. But also there's the Docker Hub, and there are other registries. And then we talked about Docker as a microservice for containers or with containers. And the difference between an application that runs 24/7 versus a microservice that is a task base, does only one thing, but does it really, really well and really, really fast, kind of workloads that are best suited for containers, because they start, they do what they need to do, and then they stop.
Yeah. And I mean, just to complement on that, there's nothing preventing you from running 24/7 applications on containers. And in fact, that's what we're doing this for this website. We're
Yep.
just making the process of bringing the whole thing up faster with containers. And in this case, uh, there's no persistent data, or the application itself is not stateful. If I bring all the instances of my containers for the application down and then bring it back up, they're going to behave exactly the same because they are based on a container image that was created with a Docker file.
Yep.
All right, so now the deployment completed, and there's a warning here just talking about this environment is being deprecated, nothing to do with the application itself. So now we can go to the Azure portal. Oops, I can click the source group, I can click the app service, and if I open my URL over here, I should see my application with the contact us and not join us. There you go. And notice that this is all capital and this one is not, because that's how I typed directly in the code of the application. So yeah, my application worked, and the whole pipeline was deployed using a Docker container with the instructions from the Dockerfile that was created. And that's pretty much it for the demo.
Very nice.
Let's go back. So just to finalize, this is again the URL for this module. From my part, I hope you enjoyed the session. I know Pierre enjoyed a lot on learning about containers.
It wasn't my thing. I'm basically kind of picked up because Amy was supposed to help you out, but she turned to Hill a couple days ago, so I kind of had to jump into it. But I'm really glad I did, because the container has never been something I've worked a lot with, but now I've gone through it and I got a bit more hands on as to how it runs, and especially how it connects with CI/CD pipelines, which DevOps is something I've been involved in the past. So I'm very happy that you guys asked me to jump in.
Yep. No, it was great to have you here. Also, there are additional sessions coming up, so we recommend you take a look at these. Design your app like a pro. I love the name. I'm sure it will be great content for you to check out. And with that said, you have our Twitter handles if you want to continue the conversation later on Twitter. Other than that, thank you so much for joining us today.
All right. Have a good day. Thanks.